All right, welcome to Modern Manufacturing 2020. We are so excited that you're here. My name is Maddie Cook, and I am a recruitment specialist here at ECTC. If you're experiencing any issues with audio or anything like that, just let us know. Okay, hold on just 1 second. All right, so we're just going to go ahead and test that audio. Sorry about that, technical difficulties. This is our third day doing this, and this is the first time we run into that. So if you can hear me, go ahead and put in the comments that you can hear me. If you can't hear me, then you're not going to know that I'm saying that. But just go ahead and drop in there if you're good. Emmy's telling me that we're good, so we're going to go ahead and get rolling. Like I was saying, I am so excited to be here with you all for Modern Manufacturing 2020. My name is Maddie. I am a recruitment specialist here at ECTC, and we're stoked to hang out with you guys today. We're going to talk a lot about advanced manufacturing, and along the way, if you have any questions, comments, concerns, anything like that, you can go ahead and put those into the chat. Just so you know, if you would like to put something in the chat, you're most likely going to have to be logged into a Gmail account or something like that to go ahead and drop something in the comments. Like you already know, I've got Emmy off screen running our technical stuff. So if you were here for any of our Facebook Lives this summer, you know how great Emmy is, and she's getting everything rolling. So let's go ahead and get into it. It looks like several of you are already watching, which is super exciting. Today we're going to focus on a few exciting things that you're going to come across in the manufacturing process, which usually starts with a problem or a need that hasn't been met, and then those in the manufacturing process actually create a product or produce something to meet that need or to solve that problem. During our time together, we're going to see several demonstrations by ECTC instructors that are using innovative technology right here on our campus and in our lab spaces that you might actually find in the industry. Among the things that you might consider as you're looking for a career path, or maybe you're considering changing your career, are some things that we're going to talk about today, and that's job security, availability, and salary. Like I said, you're going to hear our instructors talk about some of that today. But first, let's talk a little bit about advanced manufacturing and put that into some context for those of us who may not be super familiar with all that field entails. Advanced manufacturing is the use of innovative technologies to produce products or solve problems. It's a growing field with careers in all sorts of areas like automotive, aerospace, food and beverage, medical, and so much more. Here are just some of the employers in our region that you might recognize. Some of these like Altech that produces bucket trucks, Inoac, TG Kentucky, Toyotomi, that are all automotive suppliers, and Midpark that actually produces structures for things like highway signs and overpasses. And again, these are just a sampling of the many, many right here in our region, in your hometowns, and maybe even in your backyard. If you're technically inclined, you have an interest in STEM subjects, and you like hands-on work, you may consider a career in advanced manufacturing. You might also be interested to know that Kentucky is third in the U.S. for automobile production, as automotive is our state's top manufacturing sector. Just last year, Kentucky exports totaled $31.36 billion, and our Commonwealth is home to over 4,500 manufacturing facilities. That's pretty crazy to me. Now, the average annual compensation in manufacturing, we're talking about salary here, in 2018 was $72,614 in Kentucky. And Kentucky manufacturers, sorry, getting tongue-tied, Kentucky manufacturers employ more than 18% of our workforce. And if these numbers aren't enough to kind of pique your interest, CreatorsWanted.org estimate that over the next decade, 4.6 million manufacturing jobs will need to be filled right here in the U.S. You're probably tired of listening to me talk already, and that's okay. We're actually going to jump over and see what Brent in our CAD lab is working on. He's working on a project. We'll check back in with him a couple of times, actually, to see the progress on his project, and maybe you can even guess what he's creating. And just as a disclaimer, some of these clips, the things that you'll see in these videos, were actually recorded pre-COVID. Currently here, we are following all of our Healthy at ECTC guidelines. So let's go ahead and check in with Brent.
Hello, my name is Brent Doty, and I'm the program coordinator for Computeraided Drafting and Design. Basically what we do here is we solve problems. And actually I have something up there on the computer that I've been working on to solve a problem for myself. But what my students do is, we work on projects and different assignments, and the whole idea is to give them some kind of a, whether it's create a model or create drawings that other programs could use, like CMM. They can make the parts that we actually create. So we work with all the other trades and other areas to solve a problem, and they're the ones that actually end up doing the fixing sometimes and completing the job. We're getting ready to print the part that I've got up here on the screen, and when you come back, we'll see how it's doing.
All right, thanks, Brent. That is super awesome. I'm excited for you all to see what he's been working on. Do you think you know what he's making? If you do, go ahead and put that in the comments. Just as a reminder, if you want to be able to comment, you're probably going to have to log into a Gmail or a Google account. Laura, I see that you've commented. Thank you for that. You can hear us. If you can still hear us, that's good. If you can't, put that in the comments too. But you guys can go ahead and put your guesses there in the comments, and maybe some of you might be right. That would be pretty cool. But we're actually going to check back in with Brent a little bit later to see some of the progress on his project. But since we don't have any more, man, the tongue tie is really crazy today. Any more comments right now, we're just going to sail right into our next, our first full demonstration. And I'm super excited to share this one with you guys. I got to sit down with our Computerized Manufacturing and Machining Program Coordinator, Grant Logston, and one of his students to talk about advanced manufacturing, what they do in the field, and how his students are preparing for a career in the advanced manufacturing field. Hey, so Grant has an EDM demonstration set up for us in the machine shop. Let's go check it out, but safety first.
My name is Grant Logston. I'm Program Coordinator of the Computerized Manufacturing and Machining Program at ECTC. I think it's a great field to pursue because if you're a student that likes to work with your hands, you like making things, you like taking things apart, putting things together, it's just a great field because we run all kind of different machines, and it's just a great field. We're going to use a wire EDM. It's an electrical discharge machine, a very high-tech machine, and we're going to cut out a 36-tooth spur gear that's actually going to be used on one of our other machines. The work here begins on the computer with Mastercam software. Our students will draw the part, assign a toolpath, generate the code, and then load it on a flash drive that will be uploaded to the machine. After the program is loaded, the EDM, which is an electrical discharge machine, uses 10 thousandths brass wire to cut out a precision part that will actually be used on another machine here in the shop. You can use any material as long as it's electrically conductive, but here we're cutting a gear out of aluminum. The brass wire comes into close contact with the work but never touches it. As the machining begins, 30 to 40,000 sparks per second will jump from the wire to the workpiece, exploding a path for the wire to follow. The wire follows the path with extreme accuracy to cut out the profile of the part. These machines are incredibly accurate, and it takes extreme precision. The EDM can cut materials within 0.2 of a thousandths accuracy. That's like taking a sheet of paper and slicing it thinner 20 times. and EDM and machines like it are used to make parts for aircraft, tool and die parts in automotive manufacturing, for surgical equipment in the medical field, and just about anywhere there's a need for extremely accurate parts.
Hi, my name is Holden. I graduated from LaRue County High School. I'm a student at Elizabethtown Community and Technical College. I'm now working at Atlas as an apprentice, and I'm hoping within a year I can get up to $80,000 a year, and ECTC has helped me get there. What I love most about my job is that I get to be hands-on. We have big equipment that we work on for Toyota, the government, a lot of different companies that need giant stuff made, such as a gear that's 16 feet diameter. And it's nice seeing that we can make a difference in the industry.
I think the cool thing is some of the machines that we have are just absolutely fascinating. We'll use a computer to program something. We'll load it onto a flash drive, put it in a machine, set the machine up, hit start, and we come out with a finished product. And it is an amazing process.
All right, welcome back. I just think that's so cool at how precise that those machines are. And that's one of the things that I was really excited and interested to learn about advanced manufacturing, is that it's not large machines that are clunky in a dark, dirty basement anymore like it's commonly misunderstood to be, but it's often intricate and requires great expertise. Did you catch that Holden is from LaRue County? Shout out to you, LaRue County, if you're watching. You can put that in the comments, but it was really awesome getting to sit down and talk with him about his career plans in advanced manufacturing. So we're continuing to monitor the comments, but we're going to go ahead and check back in with Brent in the CAD lab and see how things are going with his project.
Welcome back to CAD. Right now we're working on the printing process. I showed you how the creation process went, and now we're working on the actual making of the part. And we're using some filament here. This is a black color, it's a PLA. There's some other materials that we can use, and this is actually what we call additive manufacturing. It's similar to CMM, except it's the opposite, where they do subtractive and they start out with a block of material, and we just start out with this material here and it actually creates it. So this part takes about an hour to print. Some take longer, some are shorter, just depends, but we'll check back here in a little bit and see how it looks. Welding or welding.
This is cool. So we've seen the beginning part of Brent's process, starting with the drafting and designing on the computer, and then you just got to take a look at the actual creating and making part of the process. Did you catch that tidbit about where he talks about additive versus subtractive manufacturing? That's one of the other things that I was super interested to learn about advanced manufacturing, is that people are solving problems from all different angles. They think about it differently. Maybe their brains work a little differently, and they're solving it with different methods from different angles. And I just think that's really, really interesting. If you know what he's making, again, you can drop that in the comments and give us a shout. But we're actually going to roll on to our next stop. Hey, so I'm in the electrical technology lab with Tim, and he's got a really cool demonstration set up for us. So let's go check it out.
My name's Timothy Cordova. I'm a professor here in electrical technology. I've been doing this for 18 years. So manufacturing, there was a time where we were shipping a lot of things overseas. I think America's realized that the best stuff's made right here in the United States. So I see manufacturing as sticking around for a long time. I also see the rise of robots. Robots are going to be used. They're going to be used in our homes. They're going to be used in industry to clean things when we're gone. So there's going to be a need for people who know how to repair those items. So today we're going to be demonstrating an industrial motor controls 2 pick and place that utilizes pneumatics. It's got a photo eye sensor on it. It's computer controlled by a programmable logic controller, and you'll see it use the pneumatics to pick and place a puck off of a conveyor system. So on this machine, this student used a personal computer to create a program that's downloaded into an industrial computer called the PLC. PLC is the brain for this process, as it controls all of the functions on the components. It works hand in hand with the variable frequency drive to control the speed of the conveyor and the dispensing of the pucks, and basically how quickly everything functions. This is important because when this skill is used practically in an industrial line on a much larger scale, everything has to be timed precisely down to milliseconds and even faster. This system uses a photo eye which senses the color of the puck compared to the conveyor belt. The conveyor belt is black, the puck is white. When it sees that contrast, it triggers a sequence of events, including the pneumatics to direct the airflow to engage the slide to pick the puck up using vacuum pressure. To put this in perspective, you replace the puck with a bottle cap, and your robotic system is now assembling bottles of bourbon, Coke, you name it, even ski. So robotic technicians make generally about $65,000 a year, and that's without overtime. So when you think about overtime, think about an extra $30,000 to $40,000 a year depending on that overtime. We also have process control technicians. When you think process control, I like to think about distilleries. I think it's most cool really because when you think about the future, I keep thinking about how it's changed. So from when I started to where it is now, when I started, no robots, now robots everywhere. That's pretty exciting. And when you think about the pay that's going to keep going up and up and up with somebody who needs to know the skills necessary to work on those things, I think that's what's the most exciting.
All right, thanks, Tim. That was a super fun day getting to sit down with Tim, talking about the future of advanced manufacturing. This field is not only changing and growing rapidly, but it is one that has job security and staying power, which is really important in our world that is changing and continuing to change all the time. So that may be something that you think about. Another thing that you might have noticed in these demonstrations is the diversity of our students in the advanced manufacturing field. For example, more and more women are finding great careers in advanced manufacturing, and our instructors and those employers we work with would tell you that there is nothing that women can't do in this field. Let's go ahead and check back in with Brent. We're going to see the final finished product of what he's been working on.
Welcome back to CAD, and this is our last installment, and you're probably wondering what I was making. Well, I'll show you. It was actually a buckle for my backpack to help keep this strap from moving. I don't know if it's going to completely fix the problem, but at least I'm on the right track. Basically, the way the CAD program works is you start out by doing some hand sketches, some hand drawings on a board similar to what I'm sitting at right here. And then they move on to the computer and they start doing the same thing but on the computer. And they move from 2D drawings into 3D drawings and making the models. And then you can either go to 3D printing, you can create the drawings that the other areas use, like CMM or electrical. We work with them to create drawings that they read. We'll create the actual drawings for the solving of the problem, whether we're doing the solving or somebody else is. Most of the jobs are set up as a designer type job. They might be called CAD operator, CAD designer, or just designer. And you could be mechanical or architectural. Usually they make somewhere between $15 to $20 starting off, and it could be more. It really depends on your skill set. Well, the real reason that I like it is because it's cool to solve problems. I have a lot of students that they enjoy making things, not just 3D printing things, but actually designing something that they can say, hey, I did that. You know, like if you designed a house and you can see it built, and then you're like, hey, I drew that. That's what CAD's all about, solving problems.
All right, it was a buckle. How interesting is that? I love that he mentioned that he's not sure if his buckle or his design is actually going to fix his problem, but that it's a great start. A lot of problem solving, as I'm sure you know, is trial and error, but he's working to achieve a goal. And with all the technology that's available today, there's really not any problem that you can't solve. Brent actually put those problem solving skills to work earlier this year when the pandemic started, and we had a lot of healthcare professionals in our area that were experiencing a shortage of face shields. And so Brent and his team there in the CAD lab designed the plastic pieces that actually attach the shield to your forehead, so that you can have that in front of your face. They did those plastic pieces and made those shields, and then distributed those out to healthcare professionals in the community that needed those. And he helped solve that problem, and I know it was greatly appreciated. Brent, thanks for doing that. We appreciate you here on campus. All right, we have one more stop. Are you ready? Whew. So we're here outside the robotics lab with the engineering and electronics technology program. Marty has a pretty cool demonstration set up for us, so let's go check it out.
I am Marty Sutherland, and I'm a professor here in the Engineering Electronics Technology group. Today we're going to watch a FANUC robot simulate a weld demonstration. What you see here is a FANUC welding robot. We're lucky enough to have 5 small pick-and-place robots and this large welding robot that you would see in the local industry. Our students get first-hand experience programming these robots and running complex programs you'd see in local manufacturing. Now what I've done to set up this demonstration is use a teach pendant, the little computer I'm holding, to develop a number of steps for the robot to follow. So it follows an X, Y, and Z axis, which means that it can move up and down and side to side and even rotate. It's really satisfying to see a program developed on a computer and then translated to this powerful yet delicate machine. You might notice the small weld wire that's barely touching the steel part. We're only simulating the welding part of this demonstration just for visibility purposes. The smoke and sparks make it real hard to see up close. Our students, they get to develop this from the ground up. It's up to them to code, troubleshoot, and perfect different scenarios you'd see in the advanced manufacturing industry. Some of the career pathways that you can get into, we've got things like robotics and automation, which would get you over at Matassa, AGC, or some of the places. We've got instrumentation process control, which would be chemical plants like Dow Corning, or water treatment plants, or maybe some of the distilleries. We also have the electronics, which goes into like Raytheon, or maybe even LG and EKU in Louisville as well. Those are some of the places you could go. Now some of the salaries are starting usually around $52,000 a year. With a little bit of experience in a couple 3 years, most guys are making upwards of 100 or over 100,000 a year. When I talk to my former graduates, the main thing that they say they love about their new job is the pay. They really like that high salary. They can provide for their family, they live comfortably, they can do the things they want to do now. They like the challenges. It's something different every day for them to go to work. They really enjoy it.
Wow, I'm not sure how familiar you are with the world of robotics, but my mind was blown at all the stuff that our students are learning about how to program those robots to do all sorts of functions, from welding to cleaning to pick and place functions. And Marty and our other instructors really hit on one of the biggest draws for the advanced manufacturing field, which is pay. It's certainly not the biggest factor that makes this field enticing, but it is a factor for consideration. Our instructors spouted out a few salary figures, anywhere from $40,000 to $65,000 to even 6 figures per year. But what does that really mean? Let's put some money into perspective, all right? So the median household income for Kentucky is about $48,000 a year. And we do know that a lot of those households are actually 2-income households. So with a career in advanced manufacturing, it's highly possible that you're going to be providing for your household above the median income in Kentucky. Now, advanced manufacturing isn't only the programs that you've seen today, which were computerized manufacturing and machining, electrical technology, computer-aided drafting and design, and engineering and electronics technology, but it's also welding technology, one of the most highly paid of the skilled trades, and industrial maintenance technology, where you learn to install, repair, and maintain the machinery and systems that keeps the industry moving. All of these are 2-year degree programs here at ECTC, with the options for diplomas or certificates that can be completed in a shorter amount of time. And if you think you want to get a bachelor's degree, you can follow some of these tracks within these programs to transfer into another college or university. Now, if you're thinking of something like engineering, make sure you check out options to knock out those general education classes for half the cost. Our Associate of Science degree can be completed with electives in any of these advanced manufacturing programs to set you up for a bachelor's degree that will lead you into the manufacturing workplace. So if you're ready to learn more information about any of these programs or any of the options that we've talked about today, you can visit our website at elizabethtown.kctcs.edu, and there you'll find information on all of our programs, our scholarships, and the application process. And if you need any help along the way, please don't hesitate to reach out to us at ECTC, sorry, I paused, I thought I was going to get it wrong, ECTC recruitment at kctcs.edu. Thanks so much for hanging out with us today. It's been a blast.